see, we are continuing with logic minimization. Okay, remember when we started, we kept talking about ones, but then somewhere in the beginning of the course, what we said is there is really another discrimination against the zeros. Zeros and ones are as good. Okay, and a zero is supplied by supply zero, a one is supplied by supply one. And so it's just easier for us to look at ones because it's positive logic. Okay, but then when you are mapping a Karnaugh, when you are coming up with the expressions from a Karnaugh map, instead of looking at the ones, why not look at the zeros? Okay, didn't we say that zeros and ones are equal? Fine. So let's look at zeros. And then instead of min terms, let's look at what is referred to as max terms. The only reason we use the word max term because really there is nothing max to it. But then since we have min term, then the opposite of it will be max term. So there is no minimum to that, there is no maximum to that, or anything like that. So they're just words that are made up for this purpose. So let's look at max terms and look at Karnaugh Maps again. Here I have a three variable map, okay? And this three variable map has 3 zeros in it. 0, 0, 0 gives me a 0. And no, this is the row number. Okay, not to get mixed up with the variables A, B, C. And this gives me W. But then I see more ones than zeros. So I think like this. Well, what if instead of doing ones, I yet consider zeros? But see, I'm not used to considering zeros. So why not look at W bar instead of W? And then at the end, I bar it. I complement it. Okay? Because so far, I'm only used to taking ones. So for my W bar is 1. I'm looking at W bar now. Is 1 if A is 0 and B is 0 and C is 0. It is 1 also if A is 0, B is 1, and C is 0. It is also 1 if A is 1, B is 1, C is 0. Okay? Then what do I do? Then I have it all written down here, but I like to write on the screen. I'm going to double bar this because see, this is what I came up with for W. What if I, but what I really want is, what I'm writing here is W bar, but what I really want is W itself. So I bar this and also bar the right hand side. Okay. Apply De Morgan's. De Morgan says break the bar, the top bar, change the operation to its opposite operation. So or changes to and. Break this or changes to and. So what I come up with is A bar, B bar, C bar bar, ended with A bar, B, C bar bar, ended with A, B, C bar bar. Okay? Now let's apply De Morgan one more time. This time, let's break the, let's take these individual terms. Okay? Break this, and then change the operation. I have ands here. Okay? Change them to or. Break this, break this, break this, break this. So that becomes, the first term becomes A or B or C. Okay. There's a mistake here. The second term becomes A or B bar or C. The second term becomes this after De Morgan's. The third term, again after De Morgan's, becomes after De Morgan's becomes this. Okay? Which is W. So, because I was used to doing ones, I did W bar and then I applied the De Morgan twice to turn it into W. Now that I see this, I say, couldn't I grab the same expression directly from the truth table instead of doing the W bar and then doing the Boolean expressions or expressions and then doing the De Morgans and all that? Couldn't I just write this? Look, the way I could do is forget about W bar. I could look at W and only look at the zeros of W. Okay? I can look at this zero, say, this is a max term of the function, and this turns into A or B or C. Let me use different colors here. I could look at this and directly write A or B or C. I could look at the I'm trying to come up with it. I could look at this zero and write A or B bar or C. And then I could look at this one, third one, and then write A bar or B bar or C. Okay? So, instead of looking at ones, I'm looking at zeros. Instead of taking A, B, C and ANDing them, I am ORing them. Instead of A0 for A bar, A1 for not A, just A, instead of doing that, what I'm doing is if I have a 0, I don't put a bar. If I have a 1, I do put a bar. And then I'm coming up with these three terms here. And then instead of ORing them, which I do in the usual case, I will AND them. Okay? These zeros in W, they're called Maxterms. Instead of writing sum of minterms, I can write product of Maxterms. What Maxterms? 1, 2, and 6. What is 1? Sorry, this is 0. 0, 2, and 6. What is 0? 0 is A bar, B bar, C bar if you take the min term, but if you take the max term, 0 becomes A or B or C. 2 is in max term form is A or B bar or C. 6 in max term form is A bar or B bar or C. Okay? So where you have a 1, you have a bar. Unlike minterms, where when you had the 0, you had a bar. Let's do the definitions. So we have already seen that where you have zeros in your truth table, now these are called max terms. This is a sum term. This is a sum term, this is a sum term, this is a sum term. What you have is sum of products. Sorry, product of sums. Okay, so this is wrong. You have product of these 3 sums. So this is POS. But then this product of sum is a special product of sum because each one of the sums is a max term, and therefore this product of sum is standard product of sum. So everything that I said before, just change it. Min term is max term. Sum product term is sum term. Instead of summing the products, you are producting the sums. Okay? And then instead of taking zeros as bar, you are taking 1 as bar. So let's do Karnaugh map for this. One alternative would be to, let's say that this is my W. And one alternative would be to do the W bar, and I'm going to do that. See, W bar, you take W bar, and that is, take the ones. The ones are A bar, C bar, ORed with B, C bar, B, C bar. And then double bar it, which is this. And then apply De Morgan's, which is this. And then apply De Morgan one more time, which is this. That's one alternative. The other alternative is directly come up with this expression from the Karnaugh map. So let me do this on the right-hand side, okay? I'm not going to think mean terms again. I'm not going to think product terms again. I'm thinking sum terms. I take the blue map, which is 2 zeros. Okay? This is a prime implicate. This is a prime implicate. Because there is no other implicate that completely covers it. The other one is also a prime implicate. Because there is no other implicate that completely covers that. The blue one is an essential prime implicate. Why? Because it has at least a max term that no other prime implicate covers it. The red one is also an essential prime implicate because it has at least a max term that no other prime implicate completely covers it. And therefore, I have all my essential prime implicates. Let's do the blue one. The blue one A0, C0. So it becomes A or C. Okay? Take all the variables, and then 0 means don't bother them. The red one is B is 1, C is 0. So it is both B and C must be included in the sum term, but then B is complement. Like taking the 1 on B of B and turning it 90 degrees, and that becomes B bar. What do you do with these two sum terms? You multiply them, or you find the product form of it. And therefore this is product of sums. Is this standard? It's not. Is it minimal? Yes, it is, because you followed the rules for minimization of Karnaugh maps. Here is another example. This has more zeros in it, and I will go fairly quickly through this. Let's see. I have okay, that's a good one. Okay, so I will not go fairly quickly through it. The red one is essential prime implicate, EPI. The black one is EPI because it has this 0 that nobody else covers it. How about the red one? The red one has this 0 that nobody covers it. Okay? So I will start by writing the red one and the black one. So I'm going to write it. The black one becomes A or the black one. The black one becomes A or C bar. Essential. The red one becomes A bar or C. Okay? Have I covered all the zeros? Let's see. The red one covers these two. The black one covers these two. I have 1 0 that I have not covered. What are my choices for covering that 1 0? Okay, I have two choices. One choice is to do this. Another choice is to do this. Okay? And therefore my function is not unique. I'm going to do either the blue or the dark green. The dark green becomes A or C bar. Let me make sure it's correct. No, B or C bar. B or C bar. Right. And the blue becomes A bar or B. Okay. And this is the solution I have here, but I have two alternatives. If I want to write this in its standard product of some form, it becomes 1, 3, 4, 5, and 6. Okay? So that's example of Maxterm. What we're going to do next is go into timing, which is extremely important.